In this video, I'm going to show you how you can build a macro with a macro recorder and then insert what you recorded in another macro to process an entire folder of images. So here we are with the same image as before, and we're going to record the different steps that are required to segment nuclei with the same steps that we used with the CLIJ assistant. So to record each step, I'm going to open the macro recorder. So if you go to Plugins, Macros, Record, every single step is going to be recorded here. So first thing we do is to apply a Gaussian thresholding. If I go to Process, Filters, Gaussian Blur, I'm going to use kernel of 2. All right. Then I'm going to threshold it. So if I go to Image, Adjust, Threshold, and I'm going to use 1. That's fine. Okay. What is really important here is to check the dark background, right? If I don't do it, you see you threshold everything that is below the threshold, corresponding to the background. If I check dark background, everything that is above the threshold, here we can see with the histogram, is selected for the object. That's what we want to do. So then I can apply it to get the masks. So now I have a binary image. I want first to fill the holes in case you have some holes inside your nuclei, even if it's not the case here. So if you go to Process, Binary, then you can go to Fill Holes. Then I want to separate the nuclei that are touching, so you can go to Process, Binary, and apply a binary watershed. So it's not perfect, but it allows us to separate some of the nuclei, like in here or here. And last thing you might want to do is to obtain a region of interest for each single component, each connected component. So then you can do some measurements. And there's an easy way to do it when you have a binary image with objects that are separated like this. You can just go to Analyze and then click on Analyze Particles. You need to check Add to Manager. So then every single component, which is convex, which is the case here, is going to be added to the right manager. I click on OK. Now you see you have a bunch of regions of interest that are actually overlaid on your nuclei here. All right. So if you look at this, we recorded each single step. If I click on Create, I get an ImageJ macro, and the ImageJ macros are pretty easy to read. So you see here, first thing is to run Gaussian blur with a sigma of 2. Second thing is to do auto threshold with long dark. So as I said, just this is used because we want to have the objects that are bright, dark background, and so on. All right. So this I can just keep it as is, and if I close everything, now if I open again the image, and that I run the macro, get the same result. The good thing when you have macros is that then you can also run the macro on a different image, like this. You can see what you obtain. So in that case, it also seems to work pretty well. So you can go that way and open and do it again. But you know, the interesting thing when you try to automatize everything is that you can actually automatize everything, and I don't have to open each image and do this. I can just call a macro where I'm gonna insert these different columns. So now I'm gonna open a skeleton of a macro here, which actually have some input parameters. First one is the input directory, the output directory, and the file suffix, which is what ends the images that you're going to process. And just to go very briefly over this, you first call a function which is called process folder, and in this process folder, you're just going to go in the folder which is defined as an input, and you're going to go through all the files that end up with your suffix, TIFF in that case. And when you, for each of them, you're going to open it and then call a second function, which is here. And so here you can do a bunch of operations. It's a little bit more sophisticated than the one when you use the templates. It's just that you start by closing all images, with resetting the array manager. So if you have rows that are in your array manager, they're going to just be removed, and clear the results. And then do your functions, and when you're done, again, you close everything, and you reset your array manager. So if I go back to my macro, I just copy and paste this into my macro skeleton in here. So you can just put it, so indenting the lines. So this one is, is useless because it's commentary, so I can just remove it. This is not necessary, but it's easier to read. And then if I run this, so now I have parameters to define. So I'm going to define an input directory. So it's going to be on the desktop here, and it's going to be in image analysis. All right, so I selected the right directory. I don't have any output, and that's not a very good way to do it. We'll see how we can change that. For now, I'm not going to find this. I'm just going to hit OK. As you can see now, it's processing everything. And like this, I processed all the images that I processed all the images, but I didn't get any information. So I'm not going to go into the details here, but I'm going to actually open this macro, which I wrote before. So it's the same thing than we had before, but there are a few things that are important to do. First of all, as you can see, I added commentaries to really explain what I do. So if you go back to our workflow, apply median filtering. So here it's with the median, not the Gaussian. And then apply Wong, and then fill holes, and then binary watershed, and then add line. The other thing I do, which is really important, is to actually process your images and be able to visually inspect your results. And that's why I do this. Here you open the image again, you overlap arrays, you do the measurements, so you actually do your measurements on the real image in case you want to do some, if you want to measure the intensity you have in your channel. So in that case, it's not very interesting, as we only have one channel, which is DAPI, which is not going to be very informative. But in case you have several channels, it's really important to have the measurements of your on your original image, and so that's for the measurement. And then I just enhance the contrast and flatten so I can visually inspect my results. I do all the measurements and everything, and at the end I save the results. So if I run this, so the same input directory. Now I'm going to define an output directory. So I'm going to go on desktop, same folder, macro, and I'm going to create So you can do it directly in the Fiji window. I'm going to call it output. And now I'm going to run it again. So it doesn't take a long time. What takes time, you see, is the measurements, right? So you see it segment, and then there's a few seconds when that are used to do something, which is actually the measurements through the line manager. And if I now go to my folder here, not this one, this is the Fiji folder, sorry, here. If I go to the output directory, I have a visual inspection of the results. And this is really important. When you do batch processing, you can always apply some processing to a bunch of images. And you can do it, and except if you have a bug in your code, it's going to process everything. It's going to give you some numbers, and then you can do an analysis and do some conclusions. But sometimes it might not work. So for example, here your thresholding might not work with some images, or you might have some images that are corrupted in the acquisition process, or anything. And if you don't look at your results, you have no way to know that you made a mistake. Here I can look at my results. I have my original image and the nuclei that are segmented, that are overlaid on top. So it gives me an idea. So for example, you can see that here, definitely this should have been 2 nuclei instead of 1. But depending on the quantification you want to do, that might be okay if you just do a few mistakes. And you can go through your results, and here, very importantly, you see that you made a huge mistake, and it's because there was some problem with the acquisition. We can go back to the image. That's let me just 1, 2, 3, 4, 5, 6. So if I go in my input image, 1, 2, 3, 4, 5, 6. If I open it with Fiji, can directly see that there was a problem during the acquisition, and that's why the segmentation was messed up. So either you go back to your segmentation, segment it better, maybe with manual annotation, or you just disregard this image. But if you don't visually inspect your results, you have no idea that you made a mistake on this image. And you can keep going. And you can see that for the other images, it seems to be okay. Make a few mistakes for segmentation, but it will depend on what you want to do. Obviously, so here, for example, there's a huge, that's definitely not right. That's probably because Wong is too sensitive, meaning that the threshold is a bit too low. Of course, nowadays you could use deep learning, which would be much more powerful. We have the Stardist plugin in Fiji, for example, and it would be much easier with Stardist to get a good segmentation. But here, the idea is just to see how you can build a macro. And if I go back to my output, there was one result, which is it gives you area and then something. So here, it's going to be hard to know which area corresponds to which nucleus corresponds to which file, and that's where you need. So I'm going to reprocess the macro, and when you do some measurements, it's really important to define which is which in the set measurements. So if I go back to analyze set measurements, that's where you define which features you want to extract. So for example, the area, but maybe the centroid to know where the nuclei are. And then if you were to have other channels, maybe intensity, like the mean intensity for each channel would be interesting. Here, as we only have the nuclei, probably area and centroid, it's going to be good enough. If you want to have in your file also to know where the nuclei come from, you can just check display label, and then we'll have this information. So I'm just going to click on OK. So I closed the file, so that should be fine. Now I can run. It's going to run with the previous parameters, so I can just hit OK. It's going to process every single image again, and we just saw that the image that is problematic. It's fine. Let's just process everything, and then open the Excel file, CSV file. You can see how it goes, so it's almost down now. Alright, it's down. I can open it. And now you see I have the area and the coordinates of the centroid. And I also have a label which tells me which image this comes from. So for example, here, this is the first image. And it's still the first image, and now it changed. You see, this is the first one, this is the second one. They don't have the same name. So I had 104 nuclei in the first image, for example, and then I have all the other nuclei for the second image, and so on.